But we have discovered, as a race, 7 Earth-like planets orbiting a star that's a veritable stone's throw from here by comparison to many of the previous discoveries. But discovering 7 in the one system? What sort of a solar system is this?
It's a very remarkable discovery. Just to give you a little bit of history first, this is discovered by what is known as the TRAPPIST telescope. It's in the Atacama Desert in Chile. It's operated by Liège University and Geneva University together, although it was predominantly put in by the Belgians.
That's quite a mixture.
I know, it is. The European Southern Observatory in the Atacama Desert at La Silla it's a collection of telescopes, but that is shared among many European nations. They obviously rent some space from the Chilean government for that. But they're at a very high altitude. The air is exceptionally still, exceptionally dry. So that's why you've got some of the world's largest optical and near-infrared and ultraviolet telescopes down at that location. TRAPPIST, which is actually an acronym for the Transiting Planets and Planetismals Telescope.
Gosh, I'm going to call you if I'm ever on Who Wants to Be a Millionaire. You'll be a phone a friend for sure.
So these guys, the Belgians, first of all, had a team, and in November 2015, they had a look at this star. It's got a very weird name, but it's given the designation TRAPPIST-1 because it was the first star to undertake the observations through TRAPPIST.
So, TRAPPIST-1, this sun is quite a bit cooler than ours, because if we were as close to our star as these guys are, we'd be fried.
That's true. And it's because of that nature, perhaps how these planets form so close. And that's what makes it very interesting for them. TRAPPIST-1 is about maybe 8% smaller and 11% less energetic than our sun. So it's got a smaller mass, it's a little bit cooler, it doesn't give off as much radiation as our sun. And these planets, which orbit very, very close, like the one on the innermost ring, will orbit in just over 1.5 Earth days. That's how fast it's going around.
That's a year to them.
That's a year to them. And that's it. Each of these 7 are plus or minus within range of the size of Earth. So you've got a body that size orbiting a star less than 10% the size of our sun in 1.5 days. That's phenomenal. But it can survive because of the lack of energy that's hitting it.
So are all these planets in quick succession close together?
Correct. Very close together. The 7th planet out orbits in just over 13 days. So from 1.5 days to 13 days. Each of these, we don't know for certain what they are made up of. But given the environment that they are in, it's possible that they could have water. And that's what's making it interesting.
So if you were to imagine this in terms of our solar system,
yes.
We're the 3rd planet out. So next one in is Venus, and then closest to the sun is Mercury.
Yeah.
These guys are all within that distance that Mercury is from our sun.
Drastically within that distance.
And yet they could be habitable?
That's true. I think they know for certain the inner 2, maybe the 3rd one as well, are tidally locked. So like our moon, it'll keep the same face towards that star as it goes around. They think that, like this time a couple of years ago, you and I were talking about the discovery of Gliese 182, I think it was, and its potential planets that were around that. They were tidally locked, that the twilight zone is what we can call it, I guess. The difference between day and night would be the perfect spot, perhaps, that life could take hold. And these inner planets, they could get the right amount of radiation, the right amount of heat, and the right amount of darkness, and therefore cold, that the termination zone is an ideal spot, perhaps.
Having said that, because of the nature of the sun being cooler and less energetic, probably even at midday, at its brightest, it's only going to be like twilight on the surface of these systems.
And again, this is only speculation. It will merit more observations into the future. And what is interesting is that because of its distance, it's 39 light years away, we're seeing this system as it was today, 39 years ago, which is relatively very close to find planets that are our size of Earth. 3 of which are in what would be designated the Goldilocks zone. It's just right, not too hot, not too cold. That 3 of them are in that zone to which Earth is to our sun. That, if you've got liquid water and the right amount of radiation that's pouring out from TRAPPIST-1, X-rays, ultraviolet radiation, and so on, that it could help ignite things in the activity of the atmosphere, that you will then get the precursors to life, as is assumed would have happened here on Earth.
Or eventually, when we outgrow this planet or blow ourselves up, hopefully one doesn't happen before the other, that we could consider terraforming there, maybe? If we had the propulsion systems to go that far?
Yeah, if you had the propulsion systems, I think, first of all, what might be an interesting endeavour is to send a signal. And it is practically possible within one person's lifetime, from when they're a baby, you send a signal out, hello, how are you? In some sort of, it'll take 39 years to get there, travelling at the speed of light. They get the signal and say, hi, we're fine, how are you? We'll get that 39 years later. So it's almost 80 years of a round trip. So
you want to find out if ET is there?
First, and you want to make sure they're friendly before you go there.
I might want to make sure they're friendly before I contact them. But you not send a little spy probe first. But then again, if you send out a satellite, a probe, how long would it take, given our present technology, to travel 39 light years?
I actually tried to work this out myself last night because I haven't been able to find in the media sources that I was looking how long our current speeds would get there. For example, New Horizons was able to clock in around about 37,000 miles an hour of a speed. That's huge. That's the fastest we've ever sent anything. But you're still talking, a few thousand years.
Okay.
So.
Mm-hmm. And your maths grades in school?
I was a D average.
Okay.
I was a smart kid, but D average in maths.
We can still assume, even if you're a little bit out, it's going to take a long time to get there.
Yes.
What's our next move then to learn more?
Well, I think, in my opinion, if they were to think about sending a signal now, that will depend on what dishes that we have on Earth that are large enough to send a strong signal in that direction. We might not have that, given the nature that in the southern hemisphere there might not be a dish big enough, although Australia does have a few as part of the Deep Sky Network. I think that would be the first one. Follow-up observations. The James Webb Space Telescope is going to launch late next year. When that gets up there, that will be able to take far more accurate measurements than the Spitzer Space Telescope did in conjunction with TRAPPIST-1 on the ground. So you're getting more technology up there that can see farther and far smaller detail per pixel, if you like. And that will be the next challenge. So I'd say we'll find out more perhaps in 2 to 3 years' time should the James Webb Space Telescope be successful.
And if you were on the right part of this planet and you had a regular telescope, would there be enough light emitted from this star to see it in the sky?
No, at the moment now you need, in terms of amateur telescopes like what I have, we've talked about it before, you would need exceptionally clear skies, steady viewing, and a large aperture. Maybe 16-inch possibly would be the best that you would have to use, a 16-inch reflector. Because this star, optically, from our viewpoint, is at magnitude 8.8. Now, a telescope could theoretically get down as faint as magnitude 20 to 22. So this is a very, very faint telescope. I actually don't know what was it that sparked the interest in the team to pick this particular star either. But I suppose given its chemical characteristics, its physical properties, that maybe it was a planetary candidate before. That's how they were able to find those 7 planets subsequently.
Well, if you're a fellow nerd like us, how can you find out more about the Midlands Astronomy Club?
We have our website, currently being revamped, but the information is still there currently as well under midlandsastronomy.com. We also have a Facebook page that is managed very well by our Facebook operator, Jason Fallon. And also coming up towards the end of, at the end of March, we'll have the Cosmos Star Party. It'll be our 26th year to hold it. Now officially Ireland's longest running star party. And we, of course, will hopefully have some more details about TRAPPIST-1 by that stage as well.
Yeah, you'd want to like astronomy, because I imagine if you go to that party and you're not a nerd, it'd be rather testing.
Well, not necessarily. There'll be things for the family. For example, on Friday night of the weekend, we're going to show kids how they can make a little rocket out of toilet roll inserts and cardboard and launch them on the tables inside the hotel room where we're having it in Athlone. So there's even that kind of aspect, table quizzes, lectures, telescopes.
I refer to my previous point.
It's a nerd fest.
Yes, Shawnee, thanks very much.